Alright, welcome to another video for Pre-Calculus. In this video I am working on Section 2, Chapter 10, Arithmetic, Sequences, and Series. I'm going to go ahead and get started with number 1. It's asking me to determine the common difference and then also to find the next 4 terms. And then I'm being given a sequence of numbers here, 20, 17, and 14. So to find the common difference, if you recall from the previous section, you want to subtract your following term from your previous term. So in other words, my following term from 20, my first one is 17 minus the previous, which is 20, and then that will give me a negative 3. And then the same thing for the difference between 17 and 14. I would do 14 minus 17, and that gives me the same difference. So I have found my common difference to equal negative 3. And so now that I know my common difference, I can use that to find my next 4 terms. So the term that would follow 14 minus 3 would be 11, 8, 5, and then 2. Okay? So then working out number 3 now, I'm being given 117, 108, and then 99. That is my sequence, or my series here. And I want to find the common difference, just like before, right? And then also my next 4 terms. So I'll do 108 minus 117, 99 minus 108. And then what is the difference between those 2 terms? So that is negative 9. And then negative 9 for the next one too. So there it is. There's my common difference, negative 9. And then that will help me find the next 4 terms. So it'll be 90, 81, 72, and 63. So this is one method into finding out your sequences and series and any numbers that come after that. And now we're going to dive into actually looking at the arithmetic sequence. We're looking at an actual equation that will help us, an explicit equation that will help us in finding out these numbers as well. And you can go, so for here, this is a good way to find, the next 4 terms. But what if you want to find the term that's like 50 numbers ahead or 10 numbers ahead? Rather than doing this math, to find each term, there's actual equations we can use that we can develop with given information to find much bigger terms. So let me show you what I'm talking about here. So number 10, it's asking us to find both explicit formula, and then also to use the recursive formula, to find the nth term, meaning I can find any term that I want, up to the 100, the thousandth term, without having to do each term by itself. So let's dive in here. So I'm given the sequence of numbers of 2, 5, and 8. And my common difference here, I can see here, there's a pretty simple pattern here of plus 3, right? Let me do it in red so it sticks out. So plus 3. So to find my explicit formula, okay, I have this equation that I'm being given. So I have A1 plus n minus 1 times d, which represents the difference. And you know what A1 represents. That's the first term. And then n minus 1 represents any of the terms that are following. So I can find my, so that this n represents whatever term I want to find. So I can find my 100th term. I can find the value of the A100 term. So let me simplify this formula now for this particular set of data. So here's my set, and then here's my difference. So that's my d, right? So my A1, I know what A1 is. That's 2. So a to the nth. So that's 2, and then plus my n minus 1, and then my d is 3. So now let's simplify this formula. That's 2, and then I can use distributive property here. 2 plus 3n minus 3 simplifies to 3n minus 1. So this this explicit formula, now I can find any term that I want, any term, okay? So now it's also asking me to find a recursive formula. So for the recursive formula, this is a little bit different. I'll go ahead and do this one in blue. So that one, I would express my first term, right? And then it would be a to the n equals a minus 1, an minus 1, plus the difference 3. Now this actually turns out to be, these two equations are actually very much related to each other. Now this is the recursive version of it. Now this one, remember going back to video 1, recursive, in order for me to find the following term, I must know my previous term. And so in this case, I know what my first term is. It's 2. So then now I can get the ball rolling and finding the next terms. So just as an example, if I want to find a2, the value of a2, then I use this formula, because that's a to the 2 equals a2 minus 1 plus 3. So that's a to the first plus 3. And I know my value for a to the first, that's 2 plus 3 is 5. And of course, I already knew that because right here, that's 5, right? And then if I want to find 8, that's going to be a to the third. That's my 8 is my a3 term, right? So that's a to the third equals a3 minus 1 plus 3. So that's a2. So that's my second term, which is 5 plus 3 is 8. And then I can just keep going on and on and on and on. Now, let's say I wanted to find my, there's going to be an A4 term and an A5 term and an A6 term. Let's say I wanted to just find my 6th term, but I don't want to keep doing this recursive formula and going all the way down to my 6th term. Well, this is where your explicit formula comes in, because I want to find my 6th term, so then I can do 3 times 6 minus 1 is 18 minus 1. The value of my 6th term is, it's 17, right? So my explicit formula is a shortcut from my recursive formula, where I can find values that go way beyond the information that I have. So with recursive, I have to find my A1, 2, 3, 4, 5 all the way to 17. With my explicit, I can just go ahead and jump to my 17th term. Okay, so let's work out another one of these so you can see just another example of how it works. Okay, so here I'm given a set, a series, -9, -16, and -23. So I can kind of see a different, I can see the pattern now. But just for good measure, let's go ahead and use a process that I was teaching you before. -3, -16. The difference here is -7 and -7. So there's my common difference. So that's my common difference. So that's this is my D. D equals -7. And again, this is my series of numbers right here. So my A1 equals -9. So that's important when I'm looking for my explicit formula, if you recall. Because my explicit formula is a to the n. I have a first term plus n minus 1 times difference. So that's -9 plus n minus 1 times -7. So we want to simplify this formula. That's going to be -7n plus 7 equals -7n minus 2. So this is my explicit formula. So I can now find any term that I want. I can find my 4th, 5th, 6th, 7th, 20th term without having to do the recursive formula. But it's asking me to find the recursive formula anyway, so let's go ahead and do that. So remember, with recursive, I need that first term, right? And then my equation will be a n minus 1, and then my difference is -7. So whatever I end up, whatever the value of my previous term, you're going to end up subtracting 7, which I already found out by doing my common difference, right? So just for good measure, let's find the value to confirm, find the value of the second term. That's going to be a2 minus 1 minus 7, and that's the first term minus 7. And I know what the value of the first term is. It's negative 9 minus 7 is, in fact, negative 16. So you can see how that plays out. This is my A second term right up here. Well, let's say I want to find my 20th term. Well, I can either go to my recursive formula all the way to the 20th term, or I can just say a to the 20 negative 7 times 20th term minus 2. That's negative 140 minus 2. So my 20th term will be a negative 142. Okay, well, I hope this video helped for this first set of problems. We talked about arithmetic sequence, common difference, and explicit formula, and your recursive formula. Well, we reviewed your recursive formula, and hope this helped, and good luck in your studying.